Chemical reactions. You need to memorize 5 types of chemical reactions. You need to know the name, the basic type of chemical reaction, and maybe an example of each kind. So the first chemical reaction is called combination reaction, or synthesis is another way to put it. You have a couple of chemicals, they combine to form one chemical. So it's really 2 chemicals coming together to form one chemical. Second chemical reaction is decomposition, which is exactly the reverse of the combination reaction we just saw. So flip it around the other way. You have something that's combined, splitting up into smaller pieces. For example, you have water. Even though there are 2 here, really we're talking about one substance, breaking down into its constituent parts or pieces. And so it's really the reverse of reaction number 1. The third type of chemical reaction is called single replacement reaction. It's a little more complicated, as you can see, but the formula basically is A plus BC would make a B plus AC. So you start out with this single here and a couple, and you make a new single and a new couple. They come in basically 2 varieties. One has a metal reacting with maybe a weaker metal here that's in a couple to make a new single here. What was hydrogen was in a couple, now it's a single, plus a new couple here. And then the other variety is when you have a non-metal, like fluorine, making a new couple. The fluorine is going to drive out the bromine here to make a new single and a new couple. So what's going on is these are the 2 types depending on whether it's a metal here or a non-metal. Now what you've got is the variety of strengths of metals versus what goes right here. I know hydrogen's a non-metal, but it's on the list. I made a list here of selected metals showing their relative strengths. So you can see that lithium is right at the top of the list. As I go down, potassium, calcium, sodium, magnesium, aluminum, titanium, chromium, and so forth. This is not totally inclusive, but you can see as you get down to the bottom of the list, you've got things like silver and gold and manganese. These are very weak things, and so what's happening is the zinc, being stronger, like right here, can knock out the hydrogen, which is down here with the star next to it. And anything that's stronger could drive out a weaker and make a new couple. So since zinc is higher on this table, which is usually in your textbook, or you can find a chart like this somewhere. It's called the activity series for metals. It can make a new couple with this right here and drive off this to make a new single. And then for the non-metal side, it's pretty simple. Usually we're just talking about the halogens, fluorine, chlorine, bromine, and iodine. And so fluorine is the strongest of this series. Chlorine with second, bromine third, and iodine fourth. This is right off the periodic table. These are the halogens. So if you have a non-metal in front, like this, the stronger one can drive off any of the ones below it that are weaker. Like for example, the fluorine can drive away the bromine here and can couple up then with the metal, in this case it's silver, to make a new single. This one is now released from the couple, and a new couple here. So basically in single replacement reactions, you start out with a strong single like zinc or fluorine connected to a weak couple, and then you make a weak single here connected to a strong couple. And that basically is what drives the reaction. If this is weaker than this, you have no reaction. If this is weaker than this, there's no reaction. The fourth chemical reaction is called a double replacement reaction, symbolized by 2 couples, and they're going to replace each other, make 2 new couples over here. So for example, AB, a couple, plus CD, a couple, these are combined together, would make AD. So notice now the A has gone with the D. And CB, the C, has gone with the B. It's good to point out that these are typically aqueous ionic compounds. And so there's just exchanging ions here and making new couples. Now they come in three different types, and you need to know all three of these types. The first type is two aqueous ionic compounds, which means that they're dissolved in water. You mix them together into the same solution, and you make one product which is aqueous and another product which is a solid precipitate. I put that in red because this will precipitate out and make a solid, and that drives this reaction forward. If both of these were aqueous over here, then the reaction wouldn't work. But notice this, one of these products being a solid precipitate means that this reaction will actually be driven forward. So that's the first type of reaction that has a solid precipitate as one of the products. The second one, you have two couples. In this case, one of the couples is really sodium bicarbonate, and here it's hydrogen chloride. They're going to make two new couples, and something else happens in the middle to make it a little more complicated. But technically, it's a double replacement reaction. Two ionic aqueous compounds. So just like these are ionic aqueous compounds, you can consider these ionic in water, make the following products. Now, in this time, I'm emphasizing the fact that one of the products is a gas. So when you look at the product side, you know it's a double replacement reaction if one of the products is a gas. And then the third and last one, again, is two ionic aqueous solutions. So they all have that in common. Another ionic compound, positive and negative ions, and this is also aqueous. One of the things you're looking for here is that this is actually an acid and base reaction. The products are a salt, sodium chloride, aqueous, and water. So notice in red here I'm putting water to emphasize that if water is one of the products, that drives this reaction forward. So in this double replacement reaction, you're making new couples from aqueous ionic compounds, like that. And the three differ in that if you see a solid precipitate, that drives this forward. If they're both aqueous, that won't work. If one of the products is a gas, that drives it forward because this gas leaves. And then the third one is if it's an acid-base reaction like this, you make water, and that drives it forward. And then you make an aqueous salt. The last type of chemical reaction is called a combustion reaction. You're used to seeing these fiery reactions, lots of heat given off. The basic pattern here looks a little different than the other ones. There's no A, B, or CD. You basically have a hydrocarbon fuel, and they come in hundreds of types. Hydrocarbon meaning it's usually hydrogen and carbon, with some oxygen mixed in, hydrogen and carbon. So you're looking for hydrocarbon fuel. I show you three examples here. They all have in common that they use oxygen. Oxygen combines with a hydrocarbon fuel, so the oxygen is always O2 to make carbon dioxide and water. These are the universal products of a combustion reaction. So it's very simple, really. Combustion, hydrocarbon fuel, reacts with oxygen, typically in the air, to form carbon dioxide and water. And all combustion reactions tend to have the same pattern. You can recognize them very easily.